And we're back. All right, now, as I said in the previous lecture, that we will be using this topology that we've been using from previous lectures. As you already know, we already have connectivity from one side to the next. Okay, but remember, we're using various routing protocols, right? Let's go here to router 1. Okay, let's try passwords. Capital, Cisco, enable, student. Okay. All right. So if we do a show IP route to look at the routing table, what we have? We have EIGRP. The administrative distance is 90. All right. Okay. So that took over RIP. If you do a show start, not a huge configuration. Just hit the space bar to go down. You'll see it. You see, you have EIGRP, we have RIP, default routes, static routes in the middle, but we changed the administrative distance on the static routes. Hint, hint, they're 150, right? So what would happen if we would configure OSPF? Now, OSPF, as you know, it's a link state routing protocol. So we actually have to advertise the entire network, not just a classful boundary. Different. So here we have the 192.168.1.0, that's fine. Here we have the 10.1.1.4. All right, so let's go ahead and start configuring OSPF. Okay, config T, router, OSPF. Now, obviously, you can pick from 1 to 65,535. That is a process ID number that's local to the router. Then we put in our network statement, 192.168.1.0, wildcard mask, 0.0.0.255. And I like area 51. So we put that. Then we do the next network that we're connected to, which is the 10.1.1.4. See, I'm putting the actual network that I'm connected to. 0003. It's a 252 mask. Area 51. That is correct. OSPF will be running for CCNA certification purposes in a single area OSPF. They will not be asking you questions on multiple area. Know about multiple area because you're going to see it out there in the real world. But for the CCNA purposes, this is it. Single area OSPF, single process ID number. This is the type of configuration you need. That is it. Do WR. Straightforward and to the point, ladies and gentlemen. Okay. All right, here we got the username. Diaz, Apple is the password. All right. If we do a show IP route here, you'll see that we had EIGRP. Same thing. If we do a show start, space it out towards the bottom. We see that we have EIGRP, RIP, and static routes. But look at the administrative distance of the static routes. That's why they're there like backups. Okay. So let's go to global. We're going to configure OSPF again. Router, OSPF 1, and the only reason I'm choosing 1 because I just don't feel like remembering different numbers, so I just use 1. All right, network 192.168.2.0 0.0.0.255. It's the wildcard mask. Area 51. Network 10.1.1.4 0.0.0.3. Oops, 3. Area 51. And then one more. Boom. Oh, look at that. I found me a neighbor. Cool. And then network 10.1.1.8. Right? That's the one to our right. Wildcard mask 0.0.0.3. And then area 51. Enter. Do WR. Okay? All right. Let's do the last router. We're not going to look at the routing table just yet. All right, let's open up the last router. Diaz, Apple. Okay, global configuration, router OSPF 1, network 192.168.3.0 0.0.0.255, area 51, and network 192.168. No, sorry. 10.1.1.8 0.0.0.3 area 51. Boom. I should be getting my network that I should find pretty soon. Come on now, OSPF. There you go. All right, this is what you want to see. You want to see full loading done. All right, because there's different states in the OSPF neighborship process. Okay, so full loading done. That's a good thing. That's what you want to see. But I'm gonna do a Control Z, and right here from router 3, I'm gonna do a show IP route. And what do we see? We still see the letter D, which means EIGRP. Why is that? Because EIGRP's administrative distance is 90. What's OSPF's administrative distance? Is 110 by default. So you have two choices. You can change the administrative distance of OSPF within the routing process of OSPF, or you can just get rid of EIGRP, which is much easier. Or not really, but I just want to do that. So we're going to get rid of EIGRP, and I believe the process for EIGRP was 100, if I'm not mistaken. Come on now. Really? Okay. Do show EIGRP? No? Okay. Do show start. Okay, it is 100. Okay, so I'm going to say no EIGRP 100. No router EIGRP 100. Sorry, EIGRP 100. There goes that one. Let's go to the middle router. Let's exit there. No router EIGRP 100. I'm going to do it again because I'm just whatever. You know, I'm just going to copy this instead of typing it just to be lazy. All right, I'm going to do WR. And then let me go ahead and go to the first router. Oops, went too far out. And let me just paste that in there. Boom. Do WR. So right now, I got rid of the EIGRP. So if we do a show start, I'm on router 1. You can see that there is no EIGRP anymore in the router. And if we were to look now at the routing table, show IP route, now we get a bunch of O's for OSPF. Why? Because the administrative distance is 110, RIP 120, and our static routes are 150. So he has the lowest administrative distance, so he wins and makes it to the routing table. So again, very simple. Things you need to be aware of, things that you're going to look at. Show IP OSPF neighbor. Okay, very important. Very important. You see, this is your neighbor right here because it has the highest router ID. You are full, meaning you have a full relationship back and forth with this neighbor. You're learning it from the 10116 address on this serial, from the serial interface, I should say. Okay, remember, because this is router 1. This is the 2 network. So this, the highest IP address becomes the router ID. So it chooses that as the name of the router. So that's why it's choosing this as your neighbor ID. Okay, instead of the 10s, because there's a higher IP address. That's it. So this one thing you look at is your neighbor ID. Now show IP OSPF. Let me see. Let's do that. Let's do database. Also very important, because this is really the heart of OSPF. Okay, this is the heart of OSPF, and this is all the links that it knows about. And look at the links that it knows about is all the LAN IPs. Okay, so you can see that our router ID is 1.254 in this particular process, and these are the router link states. Okay, so definitely these are regular LSAs, things you need to look into as well. Okay, for OSPF. And one last thing I want to show you, show IP OSPF interface. All right, and we're going to do the let me do this one first. Show IP in brief, so I can see which interface I want to look at. The 10010. Really? That one? Okay. Show IP OSPF interface S0/1/0. Okay. Now, one of the things to point out is, right, fine, you see the IP address, it shows you the area that you're in, it shows you the router ID, which is the highest IP address on the router, but more importantly, the network type. It's a point-to-point network, point-to-point, which means that it's in a point-to-point network. There's not going to be that election, right, for designated router or bucket designated router because it says it's a priority of 0. Serial point-to-point will not have, or point-to-multipoint will not have a priority. Okay, serial interfaces. Let me say that again. Serial interfaces. Its priority will be 0. Therefore, you will have no backup or designated router on your network. Okay. Now let me show you this one right here. Same one I up arrowed. Show IP OSPF interface F0/0. Now we have a different network type. Now we have a broadcast. Therefore, we have a priority of 1. So this actually gets a designated router ID, which is the 192.168.1.254. Okay, but again, it doesn't really matter. It's a stub network, one way in, one way out, so no big deal. But understand the difference. You're only going to get the election if it's through an Ethernet connection. Ethernet is the one that runs actual elections. Okay, those are the ones that you're going to see their priority by default will be 1 on all of them. And completely honest, even though Cisco says you should hard code the router ID onto all your routers within the OSPF process, you can do that as well. You can change the priority on the interfaces, like this one right here, put it to a higher priority. This will be the designated router, even though this is a designated router for its own segment. But you'll see in the next lab that we're going to do, where we're going to do a DR BDR scenario. Okay, but so you can see serial point to point, right? Serial point to point, no priority. The hellos, I should mention, by default, hellos and deads, okay, those are the same. In your CCNA, you will be asked questions about these hellos. Do not change the hellos. If the hellos are different between neighbors, they will not create a neighbor relationship, all right? But in an Ethernet, all right, it's not a point-to-point, it's a broadcast. It's a broadcast, and you get a priority of 1. And you can see you still have the same hellos. All right, but it's pretty cool. We're now running OSPF. Let's check all routers to make sure, right? Verification. Do show IP route. All right, there we got those right there. All right, and now here, do show IP route. Cool. All right, no big deal. And just to take a look, one more thing to mention before we finish here, that RIP uses a hop count. EIGRP, we looked at that long number, which is a metric. Here, it uses cost. Each routing protocol has its own algorithm. RIP uses the Bellman-Ford. EIGRP uses dual. OSPF uses Dijkstra to come up with this particular number. All right, there you go. Very simple, not a big deal. All right, see you in the next lecture where we're going to do that BR or DR BDR lab. I'll see you there.